Business Calculus, Topic 5.4, Problems 8, 15, 28, and 32. Okay, we want to take the indefinite integral of this, so I'm going to convert everything to exponentials inside here. Sorry, not the indefinite, but the definite integral, which will give us the area. So we'll make this x plus x to the negative 1 dx. Now using the fundamental theorem of calculus, we'll take the antiderivative of this, which will be x squared times 1/2 plus the antiderivative of x to the negative 1 is natural log of x. And we're going to evaluate that from 2 to 3. So we can put 3 here for all the x's. So this will be 1/2 3 squared plus the natural log of 3. Then we're going to subtract the answer from putting 2 in here for all the x's. So it'll be 1/2 2 squared plus the natural log of 2. Okay, now 3 squared is 9, and 9 times 1/2 is 9 over 2. So plus the natural log of 3. Then we have here 2 squared is 4, divided by 2 is 2, and plus the natural log of 2. From here, I'm going to change all my signs on this second term here. So this will be a negative 2 minus natural log of 2. And putting the 9 over 2 together with the 2, this will be negative 4 over 2, which will be 5 over 2. And I'll have plus natural log of 3 minus natural log of 2. Now, these two can be combined as a 5 over 2 plus natural log of 3 over 2. So either one of these are we can use as solutions. Next one. Using the fundamental theorem of calculus, I want to take the antiderivative of 2 to the x. Well, the antiderivative of 2 to the x is 2 to the x divided by the natural log of 2. And evaluate that from 0 to 1. So we're going to put 1 in here for x. So this will be 2 to the 1 power over natural log of 2. And then minus 2 to the 0 power over natural log of 2. Now 2 to the 1 power is just 2 over natural log of 2. Minus 2 to the 0 power is 1, so over natural log of 2. And so 2 of these minus 1 of these gives me 1 over natural log of 2. Next, number 28. Number 28, once again, we want to use the fundamental theorem of calculus, which means that we need to take the antiderivative of this, and which will be 0 to square root of 2, and I want to change this root to an exponential to the 1/2 power. And now we use substitution to take an antiderivative of this. So all of this right here I want to treat as u. So I'm going to let u equal 2x squared plus 1. Then du is going to equal 4x times dx. So that means I can replace this with a u, but I don't have a 4 here to replace this with a 4x dx. So I'm going to put a 4 here and a 1/4 on the outside. And so this gives me the ability to change this to a du. These right here. And that's a little close there. Alright, so what we have now is a 1/4. The root, this is u, so all this changes into a u, to the 1/2, and this right here changes into du. Now furthermore, remember, these two are x's. This is x equals 0 and x equals square root of 2. Well, if x equals the square root of 2, and you put it in here, square root of 2 squared is 2, 2 times 2 is 4, plus 1 is 5, this means that now u equals 5. And here x equals 0. With x is 0, 0 squared is 0, 2 times 0 is 0, plus 1 is 1, that means u now is 1. So u is 1. So these are our new u's here. Alright, so the antiderivative of 1/4 u to the 1/2, we'll add 1, we'll get 3/2 for a power, and then the reciprocal will be 2/3, and then we'll evaluate this from 1 to 5. Okay, this right here cleans up to 1/6. And when you put a 5 here, this will be 5 to the 3/2 power. And then we put a 1 in here. This will be 1/6. And 1 to the 3/2 power. And this, we'll turn this into a root. So this will be the square root of 5 to the 3rd power, all over 6. And this will be 1 over 6, because the third root, the square root of 1 is 1 times to the 3rd power, should I say, is 1. Okay, and we can complete this, by saying this is the, let's see, 5 times 5 times 5 is 125, and minus 1 all over 6. Okay, number 32. Number 32, I'm going to convert this into an exponential. So 0 to 2, and this will be 3x parentheses x squared plus 2 all to the negative 1 power dx. Alright. Now remember, these two are x's, and I want to convert all of this to a u. So I'm going to let u equal x squared plus 2. Then du is going to equal 2x times dx. Alright, so what this means is I'm going to have to pull that 3 out to the outside, leaving behind the x squared plus 2 to the negative 1 dx. And what I need instead is a 2, so I put a 2 here. So now I have the 2x and the dx. 2x here, dx there. And then the reciprocal goes on the outside. Alright, and remember, right now, these are still x's as well. I'm going to convert everything to u's. So this will be 3/2, and we're going to change the x's from x equals 0 and x equals 2. We're going to change, see, x is 0, so 0 squared is 0 plus 2 is 2. So that'll be a 2 now. X is 2, so 2 times 2 is 4, plus 2 is 6. All of this becomes the letter u to the negative 1, and all of this becomes the du. So the antiderivative of this will be 3/2 natural log of u, and that's evaluated from 2 to 6. So we're going to put a 6 in here for u, so this will be 3/2 natural log of 6 minus 3/2 natural log of 2. And this will, and we can't leave this as our final answer, but we can simplify it more by saying 3/2 and natural log of 6 divided by 2. And the 6 divided by 2 becomes a 3, so you get 3/2 and natural log of 3. So any one of these three answers will be acceptable.